Okay, thank you. So hello, my name is Adam Auerбах. I work at a company called EPAM Systems. Hopefully you're familiar with us. We have offices across Russia, Belarus, Ukraine, EU, and of course in North America as well. I am the co-head of what we call our cloud and dev test SecOps group. And as part of leading that group, I'm specifically in charge of testing and DevOps. So I'm going to talk to you today about continuous testing and why that's not test automation. Feel free to follow me on Twitter. My Twitter handle is Bugman31. And I post articles and other talks that I do. And you can also follow me on LinkedIn. Just look me up, Adam Auerбах. I'm always happy to answer questions and talk testing. So just one slide on EPAM. So EPAM has almost 40,000 engineers. We're a global consulting firm. As part of the testing practice, we have almost 7,000 testers. Many of which are located in Eastern Europe. About half of them are automation, and we focus on all aspects of testing. And so part of what I'm going to talk to you today about is what we're seeing in the market, something that we specialize in, but this is not meant to be a sales pitch. It's more about education and helping you as you look to improve your testing practices at the company that you work at. If you have questions, please use Slido, and if you can ask them in English, that would be great. Otherwise, I'll try to use Google Translate to see what you're saying. Okay, let's begin. So I want to first talk to you about DevOps, because DevOps is the foundation of how we're transforming testing and where this concept of continuous testing comes from. So let's first get grounded on what is DevOps. So DevOps is a philosophy, and it's a philosophy around delivering high quality software quickly. And so it's not, sometimes people will say, well, DevOps is CI, continuous integration. Sometimes people will say, DevOps is development and operations coming together. That's where the DevOps comes from. But it's a philosophy around flow and improving time to market. And so when you think about it in terms of agile, you have to think about it as, okay, we have a team of developers and testers, and they're doing work. And so how do we help enable that agile team to do as much as they can do on their own in order to ship code to production and do it safely? It's not just about giving the agile team full access to production and being able to do builds and deployments themselves, but it's helping create frameworks and capabilities that the agile team can use in order to get fast feedback on features and then be able to safely promote code all the way into production. And this concept of you build it, you own it, that comes from the DevOps movement. And frankly, this is how the Agile team has to change. It's not just about writing code and testing it, but they have to understand the environment. They have to understand the CI process. They have to be accountable for the quality. And frankly, if it breaks in production, they're the people that should fix it. You shouldn't have a build versus run organization. It should be the Agile team. So this is our underlying philosophy that's going to drive everything that we do in testing. There's a couple of principles that I like to use when we talk about DevOps, and again, this will relate to testing, but first one, build once, deploy many. So many times, in testing, we have to deal with poor architecture or bad branching strategies, and so we have some clients where they have different branching patterns based on the environments, right? They're cherry picking code from one environment to the next. And when you do this, you have to test everything all over again. And so for DevOps, in order to have this very factory assembly line type movement, we want the code to compile once, it gets deployed, we run some set of tests, we move it to the next environment, we run the next set of tests, and and so forth and so on, and then can move to production. The next one is around self-service. So for testing, many times we have an enterprise group who does regression automation or performance testing or security testing. And the team, the Agile team, is doing manual testing. And so when we talk about DevOps and applying it to testing, we're talking about how to get those enterprise teams to stop doing anything, stop doing automation on behalf of the Agile team, and that the Agile team itself needs to be able to do functional automation, performance testing, security testing. They have to be able to do it. And those enterprise teams have to provide the capabilities for the teams to take advantage of them. The third one is around creating support. So when you transition into this model, people on the team are going to need help. They're going to need to phone a friend to say, hey, I don't know how to automate this object, or we have a new type of API service and I don't know how to use that, or they just get stuck on a technical issue. And so we need the enterprise teams to be able to provide support and best practices for the people on the Agile teams. The fourth one is around bottlenecks. So as we try to go faster, we're going to run into issues. Test data is going to be a big issue. We want to run our tests multiple times a day. We need data that we can reuse very quickly. Maybe you have constraints on third parties or environment. So we need to be able to understand what these constraints are, and we have to work to resolve them pretty quickly. And then the last one is accountability. We have to stop thinking about developers and testers, and I'm a developer, so I just do this. I'm a tester, and I just do that. We now have teams of engineers, and we all have to share in accountability. As a tester, I need to understand the architecture of the application. I need to understand the CI process and the cloud infrastructure if you're moving to the cloud. And as a developer, I need to understand what's being tested, how it's being tested. Frankly, I should be able to run and create tests myself. So these are the 5 key principles or tenets of DevOps and how we can apply them into testing. So I like to start with this slide to kind of show a very common maturity point for companies. And that's, we say we're agile, and typically what that means is we have several sprints of development and testing, but then there's a sprint that's required to do regression testing, or what we call hardening, making it release ready. And so when you step back and you're doing like a monthly release or quarterly releases, and you say you're agile, well, this isn't agile. This is waterfall. And so the whole point of agile is to be able to deploy code every sprint, maybe once a week, maybe every day, or multiple times a day. And so you can't have a hardening sprint or a release readiness sprint. You have to be able to do that within a sprint every day, maybe even multiple times a day. And so we get to this concept of continuous testing. So I like to write it out just to make sure that it's really clear. So I'm just going to read it. And whoever, if you're getting this translated, they can read it in Russian. But continuous testing is when all tests needed to certify an application are automated, part of a pipeline, and are responsible for determining when the build can move forward to the next step in the process. So this is the key differentiator between continuous testing and just test automation. Even when I joined EPAM many years ago, people said we did continuous testing. And what they meant was, well, we have automated regression tests and we have them integrated into Jenkins or a CI tool. Well, that's not continuous testing. Continuous testing is this. It's, I have a CI process, a continuous integration process, right, where as a developer is checking in code and creates their pull request, we have a set of tests that are run in order to say, yes, this code meets the quality gate and can be deployed into the next environment. So maybe you have unit tests, you should have unit tests, static security tests, some smoke tests, maybe a lightweight performance test. So you run code smells. So you run these checks, assuming you meet the threshold for coverage and your test pass. Then the test can be deployed to the QA environment. Then you have your next suite of tests. again, maybe you have some lightweight performance tests, maybe you start doing dynamic security tests, a smoke test, some stubbed out functional tests, and then based on the success of those tests, the build will move to the next environment where you run the next suite of tests. And this process continues to run all the way through to being ready to promote to production. This is continuous testing. Everything that I'm doing to certify the application is automated. It's all part of this process, and automated quality gates are built into the CI tooling and to interrogate the test results in order to determine whether or not I can move forward or not. If I have to have manual intervention to look at the failure, to look at the test results, pass or fail, determine whether or not I can keep going, that's not secure. That's not continuous testing. If I have an automated performance and security testing, that's not continuous testing. Ideally, you have dashboards so that the team can see when the build is failing, and then the team is enabled to see the results of tests and the quality gates, and then they can go and fix them for themselves. This is continuous testing. So you can see that test automation is part of continuous testing, but they're not the same. Continuous testing is a far greater maturity in overall testing, while test automation is just one aspect of it. So let's talk a little bit about how do you get there. So the first thing is pipelines. As automation engineers or architects or developers, we all should understand the CI pipeline. What tool are you using? How and that tool becomes the backbone of everything that we do. All of our tests need to be kicked off through that pipeline. Ideally, the test results come back to the pipeline for decisioning on whether or not to keep going. If we need to provision an environment for testing, that should happen through the pipeline. If I need data, that should happen as a task within the pipeline. So the pipeline is the backbone of what we do. And as testers, we should understand the tooling and how to best integrate our testing with the pipeline. We need to be able to automate in real time. We need to be able to automate our tests, whether they're component level tests, API tests, unit tests. They all have to be automated and done at the time of development. So ideally, we're checking in working code and working tests. They all get checked into the same Git repo. They all become part of that CI process. There's a couple best practices in the industry: behavioral driven development or acceptance test driven development. They're very synonymous. But basically, we're writing Gherkin scenarios with the developers and the product owners. We go and automate those acceptance tests while a developer is developing. Then we bring them together, make sure they work, and so forth. Test-driven development is the process of writing unit tests first and then writing code. It's up to you whether or not, from a development standpoint, that's the practice you want to follow. At the end of the day, what's most important is that we have a unit testing coverage goal, and that we enforce it as part of our pull requests or merge requests. From a automation approach perspective, it's really important that we understand the testing pyramid. This slide is a very heavily used slide for us because when we talk to clients about moving to automation or more advanced continuous testing, a lot of times they say, well, here's my manual test cases, let's just go and automate them. The problem is that those manual test cases are usually right at the UI layer. And so when you automate everything from the UI layer, you get what's called a upside down, you get the ice cream cone effect. So it's like you have a lot of UI tests, but very little API and unit tests. The problem with that is that UI tests are very flaky. They fail often. They take a long time to run and support. And what we see over and over again is that these tests are unreliable and don't give you a high, the return on investment for UI automation is much lower than for unit tests or component level tests. So component level tests are isolating the different components of your application, the UI, the API, the back end, and having a full suite of tests around that component and what it does. And then you can have some end-to-end tests that integrate between the different components. And then, yes, like ideally some ad hoc exploratory manual tests. You still need to do some level of manual testing, but I tell people, like, don't hire manual testers. If you have job recs out there for people, like, it should all be for automation engineers or software engineers and tests. You shouldn't be hiring manual testers. You still need to do some manual testing, but companies like Google, they and Netflix, they don't have manual testers, but they use vendors like ourselves to do crowd testing or test in production. And so there are other ways to do manual testing. Your testers on your teams need to be similar to engineers, and they need to be able to understand the architecture in order to automate at these different layers. Open source tools. There are really great third-party tools, and depending on your technology stack, if you're using a COTS product, or maybe you're automating an older system, you might need to use a third-party tool. But if you're trying to do continuous testing, the open source tools are the most advanced, they're the most flexible, they're the best to integrate into your CI process. And frankly, you're going to get there the quickest using open source tools. Obviously, it requires your testers to be engineers, to have some level of programming experience to take advantage of them, but these are best practice when it comes to continuous testing. From an environment perspective, we need to be able to understand how to use the cloud. When I was at a bank 5-6 years ago and we implemented continuous testing, it was the testing group that learned how to use Kubernetes and Docker in order to set up Selenium grids in the cloud to emulate the different browsers and devices. And the testing department became the biggest experts in the company around containerization because we went after our test environments before the applications were ready to move to the cloud. But you're going to need to be able to stand up all the environments that you need on demand as part of that CI process. EPAM has our own mobile cloud to help enable being able to have access to devices. And there's some really great third-party tools like Perfecto and Sauce Labs who have their own device farms and browser farms in the cloud that you can integrate into your CI process. But you have to have these integrated, immutable environments at part of your testing process and part of your pipeline. Test data is probably the #1 problem that every company is facing at some point, and there isn't really an industry standard yet on how to solve it. It usually starts where people are saying, hey, I need access to production data, and they try to do scrubbing and subsetting and replaying it into their environment. The problem with that is it's slow. And so synthetic data is actually the more recommended approach, where you're able to create dummy data as part of your pipeline prior to your test running, and then you can delete it afterwards, or you can just keep recreating them as you need. And then the other way of being able to do this is being able to create stubs and stub out the different components so that you don't necessarily need any data. But you need to have data. You need to be able to run your tests multiple times. And I tell people, like, the best way to understand this constraint is run your regression suite 3 times in a row. And does it fail the second and third time? And why does it fail? And most likely it's going to be because of test data. As I mentioned, one of the ways to solve for test data, as well as other constraints within your application architecture, is service virtualization or stubbing. There's some really great open source tools like Montebank and Mockito, and then there's the third-party tools from Broadcom and IBM and Microsystems has what used to be HP, they have their own service virtualization tool. But basically, service virtualization allows you to stub out those calls to a backend. So at a financial service company, maybe you have a mainframe processing engine. And so you're testing your mobile app, or let's say you're testing an API. And so you think you need data within that mainframe. Well, you can use service virtualization to stub out the mainframe and give all of the calls back to the API and to the front end, like with dynamic data sets. So you can run all of your tests on those other components. And then maybe once a day, you hit the mainframe. So service virtualization allows you to isolate those components and rigorously test it. So that way, when you do end-to-end testing, it's more of just like your critical transactions, your happiest paths. You're going to need to have real-time dashboards for the team. We need to understand how the testing is going and how to and where there might be flaky tests or when to investigate defects. And the team needs to understand the health of the pipeline and the progress of the code. So two really popular dashboards. One is reportportal.io. This is a tool that we've developed at EPAM. It's open source. It's totally free. Many of our competitors are using it. And basically, it uses natural language processing to go through your automated test results and quickly start to recognize what type of failure it is. So let's say you have thousands of automated tests and several hundred of them fail. So the report portal learns how to recognize the failures and will start to categorize them. Hey, this is a failure because of your framework. This is a failure because of the environment. This is actually a real defect. And so it helps speed up that triage process, and you can integrate it back into your CI tool so that you could stop the build based on the errors. We have some companies who have customized report portal and have integrated performance and security tests into it because, especially with security tests, you get a lot of false fails. And so that natural language processing engine of report portal can help filter out those false fails for security tests because it looks at the full stack trace and compares that to previous runs and how you categorize them. From a DevOps perspective, Capital One is a bank in the United States. They've done a lot in open source. You can go to CapitalOne.io, and they have a dashboard called Hygia, and that integrates into your CI tool so that you can see the code as it moves from environment to environment, and where is code getting held up because there's long-running tasks and jobs. And so it allows you to kind of do some real-time analytics to understand where is there maybe some manual tasks, where is there an opportunity for automation, or maybe there's just some buggy code holding everything up. So again, this is continuous testing. All of the tests we need to do are automated, they're part of the pipeline, and they have automated quality gates. When we talk about quality gates, these are some sample quality gates. So on the top is quality gates that are very common around functional testing. And then on the bottom are more advanced tests like security scans, like the Four Eyes check, mutation tests, pen tests. And so these are more advanced. Obviously, we want to start with having quality gates around some of the functional tests and unit tests. And then there's more advanced. But again, like this is a big maturity step for companies to be able to actually have quality gates integrated into their CI process and have them automated. Here's just a really quick example of continuous testing pipeline, so you can see the different activities that you would have in the feature branch, and then when you move to the pull request, the unit and static code, then when that pull request gets merged, the next set of tasks that happen, then moving into QA, the performance tests, the acceptance tests, and then eventually into prod. We've done some surveying, and what we found is that this isn't commonplace yet. There's still, people are still working to mature their testing process. Many people do have automated regression tests. A good portion of people have them integrated into CI, but what they don't have is they haven't maybe accounted for performance and security tests. they haven't quite solved test data management or some of those environment constraints, and they haven't automated the quality gates as part of the process. So it's still an emerging trend within the industry. Okay, so how do you get started? The first thing is value stream analysis. So this is a process in which you document what is the testing process. So the developer checks in code. What are all the steps that code goes through in order to get to production? And just put them on a whiteboard or do it virtually, because many of us aren't in our offices yet. But you just lay out all of the different activities. What's manual, what's automated, how long does it take, how many cycles does it go through, and you just lay out the entire process. And so what this allows you to do is start to figure out, okay, where are our biggest opportunities? And you can start to create a backlog around, hey, this is the work that could be automated, and you can prioritize it based off of value and effort. What's going to save the most time, and how hard is it to solve for? And so if we start solving the easiest things that take the longest time, we can start to realize some real benefits and then go from there. But this will help, number one, it helps everybody get a good understanding of the overall testing process, but then it also helps get people aligned on the prioritization and what needs to fix and how it needs to look going forward. So value stream analysis, a very critical first step to just understanding how to improve your testing process today to get closer to continuous testing. Here's one example that we did of a client where we documented their entire testing process from development to production. And what you can see is that this is a 23-week cycle. They do some level of unit testing in the first several weeks. They do regression testing, but then their integration testing is 6 weeks, and they have business users who are also doing testing at this time. And so we did some analysis of like where the churn comes from. And so we found that like the business users were finding a lot of defects as part of their acceptance tests. The regression testing was mostly manual, wasn't doing a lot. So you can see how valuable this value stream activity is, because it helps us understand the entire process and where there's opportunities for automation clearly. But then also what we can do from this is we can say, okay, this is 23 weeks. And if we automate, of course I'm pointing to my screen, which you guys can't see, but if we start to automate this and we can come up with some hypothesis around, hey, we could go from 23 weeks to maybe 13 weeks or 17 weeks. And so the importance of that is that we can create a real business case around why it's important to make this investment. Everything costs money. If we want to increase the amount of automation that we have, if we want to move to continuous testing, we might need new testers, we might need new tools. All of this costs money. And so we might just need time to do it, right? And so being able to go back to leadership and the business and say, hey, if we make this investment, we can we could shrink the release time in half. Maybe we can get 1 or 2 more releases to production because of these improvements. Maybe the release time doesn't change, but we can include more stories as part of our sprints. And so this has real tangible benefits to the business. And frankly, this is what they need to hear in order to make an investment. Many times we say, well, this isn't best practice. We really should be working this way. Like, that's great, but no one is going to spend money on doing something because it's best practice. They're only going to spend money when they know that they're going to get some type of tangible benefit that's going to help give them a market advantage. And just think, like, if your company was able to do 1 or 2 more releases a year, or maybe increase the productivity of the teams, wouldn't business leadership sign up to do that? This is just another view of the value stream analysis, from the pipeline perspective. So you can see, some of their deployments were automated, some of them are manual. You can see that all of the testing is very manual. And so this is, again, part of the value stream analysis process, documenting the steps of the CI process and how it integrates with testing, and then being able to say, okay, based off of where we can start to make improvements, this is what destination should look like. This helps us get alignment with the teams, with the business, and helps people understand what we're trying to do. So let's talk about people. So we talked about continuous testing really is driven by the move towards agile and DevOps. We talked about continuous testing, including all of the different testing aspects and being part of the pipeline. We talked about the things that you need to do in order to enable continuous testing, and then how you could get started by using value stream analysis. But what's probably most important is who's going to do this work, right? Because this is a different way of working. So the first thing that I recommend to people is taking inventory of your team. Who do you have on your team? Who is in management? Who is on the teams? Do you have mostly manual testers? Do you have just an enterprise team who are your more technical people? Are your managers more process and vendor related versus real technology people? So you need to understand who is who. When you start to implement continuous testing, you're going to need leaders on your testing department who understand everything that I just mentioned. They need to be technical people. They need to be, as you move towards agile, managers need to be less about managing the day-to-day tasks and more about mentoring the people. They need to be technologists to help enable these capabilities. They need to be able to see these opportunities. And so it might mean that you need new testing team managers. If your teams are mostly manual testers, you're going to need to inject automation into those teams. Maybe you have to initially add automation engineers into the teams with the manual testing. And then maybe eventually those manual testers have to start to move into other roles. You can train people to do automation if they have a predisposition to learning it. So do they have computer programming degrees or some type of IT degrees, maybe a math degree? Then perhaps they can be coached and trained to do more automation. But frankly, many of the people that are doing manual testers who came from the business. And so as you transform to agile, there will be new roles like scrum masters, product owners. And so potentially your manual testers could move more into the agile business-facing roles, and then that gives you an opportunity to move more technical people into the team. You can't just do this overnight, of course. There's some great subject matter expertise that you don't want to lose, but you do have to recognize that your entire team has to be technical in order to really embrace this new way of working. One way is sourcing. So, people will come to us and they'll want to go through this transformation. So one thing that we could do is, like, I could take over their manual testing. So I can do the manual testing for them. Over time, as they get more automation in place, they can start to ramp down the manual testers. Some of our clients have just asked us to start to replace people with more people who can do automation. And then, of course, you can train people. I have done very extensive, vast training on testers to help get them to do more automation. And frankly, maybe less than 50% of testers can learn how to do this. Again, if they don't have a programming background. If they do, then it should be no problem. And you start to see now in the industry, the role of quality engineer is an up-and-coming role. It's someone who can do manual testing, but also can do some level of automation. It's really important, like I said before, to make sure that you hire technical testers. We don't want to be hiring manual testers. If you have recs out there, you should only be hiring technical people. Even though you're not really ready for it, those technical people are going to come in and they're going to help find new ways of working, and they're going to start to push your team to doing more automation. Be careful of tools that promise that you can do automation with no programming language. Those tools predominantly focus on automation from the UI, and they have the same issues that you have from just traditional UI automation. Sometimes I call them like a bridge to nowhere, because at the end of the day, you're going to have to get more technical with your testers. There's no shortcutting that. There's no Band-Aid with a tool that's going to solve it. You need to have more technical testers. You need to help people as you go through this transformation. So as you try to improve your automation and get to continuous testing, you need to be doing demos to show people, like if you're going to change the tools, or if you're going to introduce service virtualization, or helping people understand the pipeline. You need to do demos and show people what this means, and because people are going to be scared. They don't know how it impacts their job, and they're going to be uncomfortable. Lunch and learns. When people are eating lunch, you can do a webinar about showing a new framework, or showing how to automate an API, or how to stub out a call to a mainframe. So lunch and learns, again, are a great way to help people get aligned. Internal conferences. So as large organizations change the way they do testing, you can showcase what people have done by having like a internal testing day at your company. You can showcase the different frameworks and different capabilities, because a lot of times people are working in their line of business, their application, and they're very narrow focused on just their stuff. And so by having internal conferences, you can get people to look at what else is going on at the company, and maybe there's ways that they can reuse other things that are already done. And this is, we have this term, it's called inner source. So being able to have like an inner source culture within your company is a great way to share ideas and drive reusability. I mentioned office hours in the beginning, so it's really important that your experts have dedicated time every week to answer questions, to help the teams as they try to do things differently. And then roadshows, we use them. I've been doing this for many years. Clearly the logo here is from 2017, so the slide is old. But doing a roadshow for leadership, being able to show them the improvements and how new ways are working. I do another talk where I talk about how like transformation really starts with testing. And so you can start to drive an agile transformation or a DevOps transformation by changing the way that testing is working. And then by doing roadshows with like senior leaders, you can start to put pressure on other teams, other departments within the company who still haven't embraced transformation. It's just a great way to show them the work that you're doing and get buy-in for their support, because ultimately you're going to need their help. At the architecture of the application ultimately will have to change. Maybe some of the way the company works will also have to change. And so using the roadshows to get momentum and support for those changes is really powerful. And as I said before, making sure your enterprise teams are focused on capabilities and introducing new technology, while the team members are enabled to do everything that they can to move code from development all the way through to production. The best way to get started after value stream analysis is just to do pilots. When I first did this 8 years ago, we started with one application, a new website we were building. We were able to enable continuous testing for that. I went to the CIO. I said, could we do other pilots in the other lines of business? So they gave me a person to work with. We created pilots in all of the other lines of business, and then they created teams who then helped drive implementation and maturity for each of their areas. And then we just used the leadership team to kind of gamify the progress that everybody was making and to reward those that were doing a better job. And it was a really great way to drive change very quickly. But pilot, because that way You're going to figure out what the biggest hurdles are, and it's going to help people get buy-in and get support very quickly. There's people in your company who want to work this way, and so how can you help them? Okay, so that's all for my slides. I wanted to just now spend maybe the last 5 minutes just going through Slido and see if there are any questions. So let me go in there. I don't see, refresh my screen, all three. Okay, I don't see any questions. Maybe, I don't know if people can ask me questions directly. But if you have any questions, I'm happy to answer them. Hey, Alexei and Igor. Okay, I think that's it then. So if you do have questions, I'll look at Slido later. Also, you feel free to reach out to me on Twitter.
Thank you.